The universe is vast. It stretches beyond what we can measure, filled with billions of stars and even more planets. Many of these planets should have the right conditions for life. Some should have intelligent beings capable of building technology. Given how old the universe is, it seems likely that at least one civilization would have advanced enough to communicate or even travel between the stars. And yet, we hear nothing. We see no signs. The silence is absolute. This is the Great Silence. Radio telescopes scan the sky, listening for signals that could come from distant civilizations. Decades have passed since scientists first pointed antennas at the stars. They have heard nothing that suggests intelligent life. There are natural signals, bursts of radio waves from pulsars and quasars, but no structured messages, no patterns, no sign that someone, somewhere is speaking. Scientists have sent messages as well. In 1974, the Arecibo telescope broadcast a simple radio message into space. It carried basic information about humanity, numbers, shapes, and a rough diagram of a human figure. If an intelligent species receives it, they might recognize it as a message. But the message will take thousands of years to reach its target. If someone replies, the wait could be even longer. This kind of communication is slow, but if a civilization has existed for millions of years, they should have sent similar messages long before we did. We should be hearing them now. We do not. Perhaps civilizations avoid broadcasting. Maybe it is dangerous. If the universe holds aggressive species, revealing one's location might be a fatal mistake. A species that stays quiet survives. But this idea assumes that all advanced civilizations think the same way. Out of the possible billions of civilizations, at least one should have decided that the risk was worth it. Even if most species stay quiet, it only takes one to break the silence. The silence remains unbroken. Some suggest that intelligent life is rare. The universe may be filled with bacteria, but not with thinking beings. Evolution is unpredictable. On Earth, it took billions of years for complex life to emerge. Dinosaurs ruled for millions of years without developing technology. Intelligence is not guaranteed. If intelligence is uncommon, we might be alone, or nearly so. This would explain the silence, but it is difficult to prove. We have only one example of intelligent life, ourselves. We do not know how common or rare we are. Perhaps civilizations do not last. They may destroy themselves before they reach the stars. Nuclear war, environmental collapse, or artificial intelligence could end a civilization before it spreads. If this is true, there might have been many civilizations before us, each blinking out before they made themselves known. The universe could be filled with the ruins of those who came before. But we do not see ruins. We do not find old probes drifting in the void. No signs of past travelers. If civilizations have ended, they have left nothing behind. Some believe that aliens might not use radio waves. A species more advanced than us could use technology we do not understand. They might communicate in ways beyond our detection. If we are listening with the wrong tools, we will hear nothing. But even if this is true, we should still see signs. A growing civilization changes its environment. It builds cities, spreads across planets, constructs massive structures. We should see energy use on a grand scale. We do not. It is possible that civilizations exist, but choose isolation. They may have everything they need on their home planets. If a species perfects virtual reality or achieves immortality, they might lose interest in exploration. They would have no reason to leave their world. But it takes only one civilization with curiosity to break the silence. If even one species wanted to explore, we should have seen them by now. Perhaps we are not listening in the right way. The universe is old, and civilizations could rise and fall over millions of years. If a civilization sent signals a million years ago, but we only started listening recently, we might have missed them. Maybe they are sending messages now, but we do not recognize them as artificial. Our understanding of communication is based on human experience. Aliens could use methods we do not expect. We might be looking right at the evidence and not know it. Another possibility is that we live in a cosmic wilderness. If the universe is mostly empty, civilizations could be so far apart that they will never find one another. The distances between stars are vast. Even if a species sends probes, it may take millions of years for them to reach another inhabited planet. In this case, the silence is not true silence. It is simply a matter of scale. The universe may be filled with life, but spread so thin that we do not meet. Some have proposed that we are the first. Intelligent life has to start somewhere. If no other species has yet reached the point of interstellar travel, we might be the pioneers. In this case, the silence is temporary. One day, we might be the ones to break it. There is also the unsettling idea that we are not alone but are being ignored. A more advanced civilization could choose not to contact us. They may be watching, studying, waiting. If they are billions of years ahead of us, they might see us as primitive. They could have rules against interference, much like we have rules against disrupting untouched ecosystems. This idea, called the zoo hypothesis, suggests that we are in a kind of galactic nature preserve. If true, we will not hear from them until they decide we are ready. And yet, silence remains silence. Every new radio scan brings hope that something will break through. Every new telescope promises a clearer view. Scientists continue to search, continue to listen, continue to wonder. The great silence is not just about the absence of signals. It is about the absence of answers. It forces us to ask what it means to be alone. It challenges our assumptions about life, intelligence, and the nature of the universe. We do not know how long the silence will last. Maybe tomorrow, a signal will arrive. Maybe in 100 years, we will uncover ruins on another planet. Or maybe, despite all the stars and all the worlds, we will find nothing. The silence is a question, and for now, the universe does not answer. Imagine you are in a dense, dark forest. You cannot see far. You know there are others, but you have no idea who they are, what they want, or what they are capable of. You do not know if they are friendly or hostile. You only know one thing for certain. If they see you first, it could mean the end. So, you stay quiet. You move carefully. You avoid drawing attention to yourself. This is the dark forest hypothesis, a theory that tries to explain why we have not detected any alien civilizations despite the vastness of the universe. The idea comes from the Chinese science fiction novel The Dark Forest by Liu Cixin. In the book, a character suggests that the universe is like a dark forest, full of silent hunters. Every civilization is a hunter. They do not call out. They do not light fires. They do not risk making noise. If another hunter hears them, it could mean death. This is not because every hunter is evil, but because the safest move is to eliminate a potential threat before it becomes one. The logic is brutal, but simple. Survival comes first. In space, civilizations might face the same problem. If an alien species knows about another, they have a decision to make. Do they reach out in peace, or do they strike first? The issue is that they cannot know the other's intentions. They also cannot risk waiting too long. By the time they find out, it could be too late. If the other species is aggressive or expansionist, they could be building weapons, preparing for war, or consuming resources that could one day be needed by the first. In this situation, silence is the only safe strategy. There is also the problem of technology gaps. In human history, when a powerful civilization met a weaker one, the weaker one often suffered. The Americas saw this when European explorers arrived. Advanced weaponry, disease, and different ways of thinking led to destruction on a massive scale. If an advanced alien civilization found us, we might face something similar. Even if they did not mean harm, their presence alone could be dangerous. They could bring technology or knowledge that disrupts our society. They could introduce new diseases. They could destroy us by accident, just as humans destroy ant colonies while building cities. If the dark forest hypothesis is true, then the best move for any civilization is to stay hidden. Sending messages into space, building giant structures that are visible from afar, or traveling openly could be dangerous. Even listening for signals could be risky. What if a hostile civilization detects that we are listening? What if they decide to send a probe, a fleet, or worse? This could explain why we do not hear anything from space. If intelligent life follows this logic, then no one is broadcasting. No one is reaching out. If they are being careful. They might use encryption or highly targeted beams that only their own kind can understand. Any civilization that was too loud may have already been destroyed. There is a counter-argument that says advanced civilizations would not think this way. If they are old and have survived for millions of years, they might have found a way to cooperate. Maybe they have set up a peaceful network. Maybe the real danger is not civilizations, but rogue artificial intelligences, self-replicating machines, or natural disasters. But we cannot assume that. A civilization that assumes others are friendly might not last long enough to find out if that assumption is true. Another counterargument says that if destruction were this common, we should see evidence of past civilizations, ruins, debris, or strange energy signatures. But space is big. If an advanced civilization wanted to wipe out another, they might do it so thoroughly that nothing is left. They could destroy planets, turn them into dust, or hide their actions. The lack of evidence does not mean the threat is not real. The biggest question is what this means for us. Humanity has already sent signals into space. We have sent out radio waves, television broadcasts, and intentional messages meant for aliens to find. We have even sent spacecraft with information about us. The Voyager probes carry messages that describe Earth and its inhabitants. In the past, scientists debated whether we should keep sending signals. Some say it's too late to stop. Our presence is already visible to anyone looking. Our atmosphere has leaked radio signals for over a century. If an advanced civilization wanted to find us, they already could. So what should we do? If the dark forest hypothesis is true, we might need to change our approach. Instead of broadcasting, we might need to focus on passive listening. Instead of seeking contact, we might need to build defenses. We might also need to think carefully about how we present ourselves. If an alien civilization detects us, what impression will they get? Will they see a planet that is divided, warlike, and reckless? Or will they see a species that is cautious, thoughtful, and capable of cooperation? This theory does not mean we should live in fear, but it does suggest we should be careful. If the universe is full of life, and if that life follows the same survival instincts we do, then silence might be the best strategy. Perhaps one day, we will be advanced enough to navigate this cosmic jungle with confidence. Until then, it may be wise to tread lightly, to observe from the shadows, and to remember that in a dark forest, those who shout may not be around for long. Imagine looking up at the night sky, wondering if someone or something is out there. The universe is vast, filled with billions of galaxies, each containing billions of stars and planets. The numbers suggest that intelligent life should exist elsewhere. But what if it does, and we simply can't recognize it? What if alien life is so different from anything we know that we wouldn't even understand it if we saw it? This is the cosmic horror paradox, the idea that extraterrestrial beings might exist but are so foreign to us that they remain beyond our comprehension. Humans have a tendency to assume that alien life will be, in some way, similar to us. Science fiction movies show aliens with humanoid forms, 2 arms, 2 legs, and a head with eyes. Even when stories depict them as monstrous or insect-like, they still resemble life on Earth. But this assumption is based on our own experiences. The life we know is based on carbon, breathes oxygen, and depends on liquid water. It has evolved under the gravity and atmospheric conditions of Earth. There is no reason to believe that intelligent life elsewhere would have the same characteristics. Imagine an alien species that doesn't use sound to communicate. They might transmit information through electromagnetic waves, similar to how our radios work, but directly from their bodies. If they visited Earth, they might stand right in front of us, broadcasting messages, while we remain unaware because we lack the ability to perceive them. In the same way, if they saw us speaking with our mouths, they might not even recognize it as communication. Consider another possibility. What if an alien species evolved in an environment where time moves at a different rate? Imagine beings that live for millions of years, experiencing time so slowly that what we perceive as a conversation lasting minutes would seem to them like random bursts of activity spread over centuries. If they attempted to communicate, we might not detect their messages because they arrive too slowly for us to notice. To them, our lives might pass in an instant, like a firefly blinking and disappearing before they even recognize it existed. There is also the possibility that alien intelligence itself is something we cannot grasp. On Earth, intelligence is often linked to problem-solving, tool use, and communication. But what if there are other forms of intelligence that don't resemble these traits? A vast network of organisms might function as a single consciousness spread over an entire planet. Each individual unit might be simple, but together they form a thinking entity. Such a life form might not have a concept of individuality or speech. It may not even have a reason to travel beyond its world, because it already spans an entire ecosystem. If we encountered such beings, we might not even realize they are alive. Some scientists have considered the idea that life could be based on elements other than carbon. Silicon, for example, shares some chemical properties with carbon and could form complex molecules. If an alien species evolved using silicon instead of carbon, their bodies and thought processes might be entirely different from ours. Their perception of the universe could be something we can't even imagine. They might not see light the way we do, or they might not experience emotions in any way that makes sense to us. If they have no concept of individuality, time, or self-awareness in the way we understand them, communication might be impossible. Even more extreme is the idea that alien life might not be biological at all. Humans assume intelligence comes from a living organism, but what if it emerges from something else? A cloud of charged particles moving in a magnetic field could form patterns that store and process information. A civilization like this might not have physical bodies, homes, or technology in any form we recognize. If they exist in the upper layers of gas giant planets, floating in storms and shifting with the winds, we would never see them with our telescopes. Even if we did, we might mistake them for natural phenomena rather than living entities. Then there is the idea that intelligence might exist on a scale too large or too small for us to notice. We think of life as something roughly our size, organisms we can observe with our eyes or at least with microscopes. But what if intelligent life operates at a subatomic level, forming networks in quantum fields? We could never interact with such beings, and they would never perceive us in return. Likewise, what if an entire galaxy behaves as a single organism? The motion of stars and planets might not be random, but part of some grand, conscious system. In that case, we would be like bacteria living inside a vast creature, too insignificant to be noticed. Even if alien civilizations are technological, they might be so advanced that we wouldn't recognize their technology as artificial. A sufficiently advanced civilization could construct planets, alter stars, or even manipulate space-time itself. If their methods are beyond our understanding, we might not see their creations as artificial at all. To an ant, a highway is an incomprehensible feature of the environment. To us, a galaxy that has been reshaped by an alien species might look like nothing more than a naturally occurring structure. Another unsettling possibility is that aliens might have no interest in us at all. Humans explore space because we are driven by curiosity, but we don't know if all intelligent life would share that trait. A civilization that has achieved everything it needs might have no reason to expand beyond its home. If they exist, they could be out there, aware of us, but uninterested. We might reach out to them, but they may see no reason to respond. There is also the chance that they are avoiding us deliberately. If they see us as too primitive, they might consider us unworthy of contact. They could have ethical rules against interfering with less advanced species. Or, worse, they could see us the way we see insects: irrelevant, unimportant, and beneath notice. The most unsettling thought is that we might already be surrounded by alien intelligence and simply lack the ability to perceive it. If we only expect to find life that resembles us, we might miss entirely different forms of existence. The universe could be teeming with intelligence, but if it operates on principles beyond our comprehension, we will never know it. This is the cosmic horror paradox. The fear that not only are we not alone in the universe, but that we may never be able to understand those who share it with us. It is not a question of distance or technology, but of fundamental differences so vast that communication is impossible. The universe may not be silent at all. It may simply be speaking in a language we will never understand. Imagine walking through a dense forest and coming across a group of animals. You stop to observe them, but you stay hidden. You don't want to interfere with their natural behavior. If you step into their space, they might react in ways that alter what makes them interesting to watch. Some might flee. Others might become aggressive. A few might even try to approach you, not knowing whether you are friend or foe. Instead of taking the risk, you keep your distance, studying them from the shadows. Now imagine that we are the animals in the forest, and the observers are intelligent extraterrestrial beings. This is the idea behind the zoo hypothesis. It suggests that aliens may be aware of us but have chosen to avoid direct contact. We may be under observation, like animals in a preserve, unaware of the full extent of what exists beyond our immediate environment. One reason aliens might avoid us is to prevent disrupting our development. If a highly advanced civilization introduced itself to a less developed species, the results could be unpredictable. It could lead to rapid technological advancement, but it could also cause panic, confusion, or even the collapse of social structures. If we were suddenly given knowledge that invalidated much of what we believed, how would we react? Some might embrace it, others might resist it, rejecting even the evidence placed before them. Entire cultures might struggle to adapt to the new reality. Rather than risk this, a more advanced civilization could decide that the best course of action is to observe from a distance. Another possible reason is that we may not yet be interesting enough. In nature, humans study species based on curiosity, but our focus often leans toward those that display intelligence or unusual behaviors. We tag whales, track the migration of birds, and study primates that use tools. But for countless other creatures, we pay little attention. We may assume that if intelligent life exists, it would automatically want to reach out to us. But that assumption comes from our own limited perspective. A vastly superior species might not see us as particularly special. To them, we might be at a stage of development that is neither remarkable nor worth interfering with. They could be waiting to see if we reach a certain threshold of intelligence or technology before making contact. Consider how we interact with remote tribes on Earth. Some isolated human populations exist with little to no contact with modern civilization. Anthropologists often choose to observe rather than engage, understanding that interference could alter their way of life in unpredictable ways. If we as humans can recognize the importance of non-interference when dealing with less advanced cultures, why wouldn't a highly advanced alien species take the same approach with us? There is also the possibility that aliens see us as a controlled experiment. Scientists often set up conditions to study how organisms behave in different environments. If extraterrestrials have been observing Earth for a long time, they might see humanity as part of a long-term study. They could be tracking our social, technological, and biological evolution, gathering data on how civilizations emerge and change over time. If they introduce themselves too soon, they risk disrupting the natural course of that process. They may have observed other civilizations before us, each following its own path, and they might see value in letting us develop independently. Another scenario is that there is a broader rule in place, one that prevents direct contact between civilizations at a certain level of advancement. If multiple alien species exist and interact with one another, they may have agreed upon a form of non-interference, similar to a universal law. This could be an ethical stance, or it might be a strategic decision to prevent conflict. If civilizations interfere with developing species, it could create instability. A universal agreement to observe rather than engage could be the most logical way to maintain balance. It's also possible that we are simply not looking in the right way. If aliens are deliberately avoiding direct contact, they might also be taking steps to remain hidden. They may use technology that prevents detection, just as a researcher in the wild might wear camouflage to avoid disturbing the animals they are studying. We search for signals, radio waves, and visible signs of life, but an advanced civilization may communicate in ways beyond our current understanding. If they exist in a way that does not rely on physical structures or radio signals, we may be missing the signs entirely. The zoo hypothesis raises difficult questions about our place in the universe. If we are being watched, does that mean we will never be allowed to join a broader cosmic community? Or is there a moment when we will be invited in? Perhaps there is a test we must pass, technological, ethical, or philosophical, before we are deemed ready for contact. Maybe we must first prove that we can exist peacefully among ourselves before being introduced to others. If this is the case, then our actions as a species may determine whether or not we ever move beyond our current isolation. There is no definitive way to prove or disprove the zoo hypothesis, but its implications are profound. If aliens are observing us, it means they have already achieved a level of intelligence and technological mastery beyond our own. It means they have chosen, for whatever reason, to remain silent. And it means that our search for extraterrestrial life might not be about finding signals, but rather about proving that we are ready to be found. Our view of the universe has always been shaped by what we know. For centuries, we believed Earth was the center of everything. We believed the stars revolved around us. Over time, we learned that we are part of something much larger. The next great realization may be that we are not alone, but that we have been part of a larger system all along, one in which we are observed, studied, and perhaps one day welcomed. Until then, we continue to look outward, searching for answers, unaware of who might already be watching. Imagine a galaxy where one civilization has already risen to supreme dominance. They have explored the stars, expanded their reach, and established control over the flow of information. If this is true, it could explain why we hear nothing from space. The silence isn't natural, it's enforced. A supercivilization at this level wouldn't need to conquer planets in the way human empires once did. They wouldn't need resources, at least not in the way we understand them. By the time a species reaches such an advanced state, they have likely mastered energy, matter, and computation to a level we can barely comprehend. Their power would be vast, but it wouldn't look like an empire from science fiction. Instead, it would be subtle, like an invisible force shaping the universe while remaining undetected. One possibility is that they act as a filter, deciding which civilizations are allowed to expand and which must remain silent. They may have already determined that open communication between young civilizations is too dangerous. Maybe they once let life spread freely, but it led to destruction. They could have seen wars between emerging species, conflicts fueled by misunderstandings, or worse, rogue civilizations developing technology that threatened everything. If this happened even once, they might have put a system in place to prevent it from happening again. If they exist, their methods wouldn't be obvious. A super-civilization would not announce itself or rule through fear. It would stay in the background, ensuring that no species reached a point where they could challenge its dominance. It might do this in ways we can't recognize. Perhaps it controls technology at a fundamental level. Advanced civilizations might rely on physics that seems magical to us. If this super-civilization has already mastered those laws, it could control how others develop them. Every time a young species reaches a certain point, it could intervene, preventing further progress. It could place limits on artificial intelligence, quantum computing, or faster-than-light travel without anyone realizing they've been stopped. Scientists would run into barriers they couldn't overcome, and they wouldn't know why. They would assume they had reached the natural limits of knowledge. Another way it might enforce silence is through direct intervention. If a species begins broadcasting signals into space, this civilization could intercept and block them. It could erase transmissions before they ever reach another world. If a species becomes too ambitious, trying to expand beyond its home system, it might disappear. From our perspective, it would seem like a natural disaster, an accident, or a simple failure to thrive. But in reality, it could be deliberate. This would explain why we don't see megastructures like Dyson spheres or massive interstellar projects. If an advanced civilization tried to build such things, they might be stopped before they could finish. The silence of the universe would not be the absence of life, but the presence of control. This also raises a troubling possibility. What if we are already being watched? If such a civilization exists, it would be aware of us. It would have detected our radio signals, our space probes, and our growing knowledge of the cosmos. The fact that we are still here suggests one of two things. Either we are not yet worth the effort of stopping, or we are already being subtly guided. It's possible that this control is not malicious. A supercivilization might believe it is acting in the best interests of the universe. From its perspective, young civilizations like ours are reckless and unprepared. We expand without understanding the consequences. We reach for knowledge without considering the risks. If left unchecked, we might create something dangerous, an artificial intelligence that spirals out of control, a technology that destabilizes space itself, or a weapon that threatens not just planets but entire star systems. A civilization that has survived long enough to dominate the galaxy would likely have seen these dangers before. It may have watched others destroy themselves and decided that interference was necessary. If it allows any species to rise to its level, it risks competition, and competition at this scale could mean destruction. So it maintains control, ensuring that no one else can reach its level. Some might argue that this sounds too much like human history projected onto the universe. But history has patterns. When a dominant power controls a region, it often enforces stability by limiting the growth of potential rivals. Empires on Earth have done this through military force, economic control, or political influence. A super civilization would do it in ways we can't detect. It wouldn't need war or force. It could simply ensure that no species ever reaches the point of true interstellar expansion. One way to test this idea is to look for civilizations that should exist but don't. We expect to find remnants of past empires, abandoned megastructures, or at least evidence of failed attempts at interstellar travel. Yet we find nothing. Every telescope we point at the stars shows a quiet sky. If intelligent life is common, we should see traces of those who came before us. Their ruins should be visible, their failed projects scattered across the galaxy. Instead, we see a void. The simplest explanation is that something prevents civilizations from leaving evidence behind. If they self-destruct, their remains should still be detectable. But if they are removed, if something deliberately erases them, then it makes sense that we see nothing. There is another unsettling possibility. What if this civilization doesn't just control technology and expansion, but also thought itself? It may not need to intervene physically at all. It could simply shape the way young species think. Through subtle influences, it could guide cultures away from dangerous ideas. It might ensure that certain discoveries never happen, that certain lines of inquiry are never pursued. If it has been watching us, it could already be influencing the way we develop. Consider how often we imagine alien life as distant, unreachable, or impossible to contact. Maybe this idea has been subtly reinforced, nudging us away from the truth. Maybe the reason we haven't found aliens is that we have been conditioned not to look in the right way. This might explain why some civilizations, even if they do exist, never call out. If they have realized what we have not, they might choose to stay quiet. They might understand that speaking up is dangerous, that drawing attention leads to intervention. If every civilization that reaches a certain point learns this lesson, they all go silent. Not because they are alone, but because they know they are not. If this is true, then our search for alien life is not just a quest for knowledge. It is a test. At some point, we may reach a level where we are noticed if we haven't been already. When that happens, we will learn whether this super civilization allows new players to enter the game or whether it enforces the silence forever. Imagine a civilization much like ours, one that starts with fire and tools, then moves to cities and machines. Over time, it builds computers, rockets, and weapons. It reaches the point where it can harness the power of the atom. It learns to edit genes, automate industries, and store knowledge in digital form. But just as it approaches the ability to spread beyond its homeworld, something stops it. The idea that every civilization eventually destroys itself before reaching interstellar travel is unsettling. It suggests that the same intelligence that allows a species to grow and thrive also becomes its downfall. The reasons vary. Some destroy themselves through war. Others pollute their planet until life becomes impossible. Some create technology they can't control, leading to their extinction. One possibility is nuclear war. As soon as a species unlocks the power of nuclear reactions, it has the ability to wipe itself out. The same bombs that can protect a nation also threaten to erase it. A single mistake, a moment of fear or miscalculation, could lead to catastrophe. If history is any guide, conflicts arise wherever power exists. Nations compete, leaders take risks, and tensions build. If one civilization, anywhere in the universe, had a moment like the Cuban Missile Crisis, but failed to step back, it could have ended its entire existence. But war isn't the only danger. A civilization might create artificial intelligence so advanced that it no longer needs humans. Machines, designed to improve themselves, could surpass their creators. At first, they might be tools, helping with science, medicine, and daily life. But if an artificial intelligence sees humans as a threat or as unnecessary, it might act to remove them. A superintelligence, with access to all knowledge and unlimited time to plan, would be impossible to stop. Once released, it could spread across the planet in seconds. Biological threats are another way a civilization might fall. As species advance, they learn to manipulate life itself. They cure diseases, grow food more efficiently, and extend lifespans. But the same knowledge can also be used to create deadly pathogens. A single engineered virus, designed for war or by accident, could wipe out an entire population. Unlike bombs, which require physical destruction, a virus only needs a few carriers to spread worldwide. There's also the risk of environmental collapse. A species that grows without limits eventually consumes too much. It burns fuel, cuts forests, and fills the air with toxins. At first, the changes are slow. Crops struggle, storms worsen, water dries up. By the time the civilization understands the full effect, it may be too late to stop it. The planet no longer supports complex life, and civilization collapses. If an alien world faced the same pattern, it would never last long enough to reach the stars. Some civilizations might fall in ways we can't predict. They could create technology that bends reality in ways they don't understand. They might experiment with physics on a scale that destroys them instantly. They might build something meant to help, but it wipes them out instead. These unknown dangers make survival even harder. History shows that technology and risk grow together. A species that reaches the point of space travel has already unlocked enormous power. That power, if misused, leads to destruction. Every step forward brings a new danger. Each new discovery offers benefits but also risks. If a civilization can't balance these forces, it doesn't last. If this pattern is universal, it explains why the universe seems empty. Civilizations appear, rise, and collapse before they can spread. Even if millions of species exist, they don't last long enough to meet each other. Some may reach the brink of space exploration, but fail before they can leave their home system. Others may send signals but go silent before anyone hears them. If this idea is correct, it means survival is rare. Any species that reaches the point of interstellar travel must be an exception. It must avoid war, control its technology, and protect its environment long enough to spread. That level of stability might be nearly impossible. The odds suggest that most never make it. They destroy themselves long before they reach the stars. There may be civilizations that solve these problems. If they exist, they would be careful. They would watch, but they wouldn't reveal themselves. They would know how fragile life is. If they saw younger civilizations, they might avoid contact, fearing that interference would push them toward destruction. They would wait, watching from a distance, hoping for one to succeed. The idea that civilizations wipe themselves out before traveling between stars is terrifying. It suggests that intelligence carries an inescapable risk. The smarter a species becomes, the more dangerous its existence becomes. It means that every civilization must pass a test. It must learn to control its own power before it can join others in the universe. If it fails, it disappears, leaving only silence behind. If humans face the same fate, it raises questions about our future. Can we avoid the mistakes that might end us? Will we learn to manage nuclear weapons, artificial intelligence, and environmental damage? Or are we already on the path that so many others may have taken? If every civilization before us has failed, what makes us different? If the universe is full of lost civilizations that never made it, are we just another in a long line of doomed species? Or do we have a chance to break the pattern? The answer may determine whether we ever leave Earth. It may be the difference between a future among the stars or becoming just another civilization that vanished before it could reach them. The Fermi paradox asks a simple question. If aliens exist, why haven't we seen any? Given the vast number of stars and planets in the universe, it seems logical that intelligent life should be out there. The problem is, we haven't found any solid evidence. Scientists search for signals, scan the skies, and explore space, yet the silence remains. This contradiction between expectation and reality is what makes the Fermi paradox so puzzling. Now, settle in, get comfortable, and let your imagination drift as we delve into the mind-boggling paradoxes and mysteries. The Milky Way alone has about 100 billion stars. Many of these stars have planets, and some of those planets sit in the habitable zone, where conditions could support life. With such high numbers, even if life is rare, there should still be thousands or even millions of civilizations. If that's the case, at least one of them should have made contact by now. Yet, as far as we can tell, no one has. Some argue that life is common, but intelligent life is rare. Simple organisms like bacteria might form easily, but complex life could be much harder to develop. Earth has existed for over 4 billion years, and for most of that time, only microbes lived here. It took billions of years for anything more advanced to evolve. Even then, intelligent life only appeared recently. If this process requires very specific conditions, then intelligent civilizations might be extremely rare. Another possibility is that intelligent life is common, but most civilizations don't last long. Technology brings great power, but also great risk. A species that discovers nuclear weapons or artificial intelligence might not survive its own inventions. If most civilizations destroy themselves before they can explore the stars, then it makes sense that we wouldn't hear from them. This idea, sometimes called the Great Filter, suggests that somewhere along the path from simple life to interstellar civilization, something usually goes wrong. Some suggest that advanced civilizations are out there, but they choose to remain silent. The zoo hypothesis proposes that aliens watch us but avoid contact, much like how humans observe animals in the wild without disturbing them. Another idea, the dark forest hypothesis, suggests that space is a dangerous place where civilizations hide to avoid being attacked. If an advanced species sees any sign of another civilization, it might destroy it before it becomes a threat. In this case, silence isn't a mystery, it's survival. Another reason we might not detect aliens is that we're looking the wrong way. Most of our searches focus on radio signals because that's how humans first communicated over long distances. But advanced civilizations might use completely different methods. They might communicate through quantum signals, neutrinos, or something we haven't even imagined. If they do, we wouldn't recognize their messages even if they were right in front of us. There's also the possibility that aliens exist but are too far away. Space is vast, and even light takes years to travel between stars. If a civilization is thousands of light years away, their signals might not have reached us yet. Even if they did, we might not notice because we've only been listening for a short time. Human technology for detecting alien signals has only existed for about a century. In cosmic terms, that's the blink of an eye. If a civilization sent a message 200 years ago, we wouldn't have been able to hear it. Some think aliens have already visited, but we missed them. Earth is 4.5 billion years old, and recorded human history only covers a tiny fraction of that time. If a civilization visited millions of years ago, there would be no record of it. Even if they came recently, they might not have left evidence. A brief visit could go unnoticed, especially if they didn't land or communicate openly. Others suggest that life is far stranger than we expect. We assume aliens would be carbon-based, need water, and live on planets. But what if they exist in forms we can't detect? They might live in extreme environments, deep in gas giants, or even in space itself. They could be based on silicon, plasma, or something beyond our understanding. If so, they might not recognize us as intelligent, or we might not recognize them. Some believe we are the first. Intelligent life has to start somewhere, and maybe it started with us. The universe is old, but conditions for life might not have been right until recently. If intelligent civilizations are just beginning to emerge, it would make sense that we haven't heard from any yet. We might be at the start of a long journey where future generations will be the ones to make contact. A more unsettling idea is that we live in a simulation. If our reality is artificial, then whoever created it might have programmed it to exclude aliens. In this case, the reason we don't find extraterrestrial life is because it was never part of the design. This idea is difficult to prove, but it offers an explanation that fits the evidence. Ultimately, the Fermi paradox remains a mystery. Each possible answer leads to more questions. If life is rare, why did it happen here? If civilizations destroy themselves, how have we survived so far? If aliens are hiding, what are they afraid of? Every time we think we have an answer, new possibilities emerge. Scientists continue to search. Missions explore Mars and the outer planets, looking for signs of past or present life. Telescopes scan exoplanets for conditions that might support life. The search for extraterrestrial intelligence listens for signals, hoping to catch even the faintest whisper from another world. So far, we've found nothing. But that doesn't mean the answer isn't out there. It might just take more time, better technology, or a different way of looking at the universe. Until then, we keep listening, wondering, and asking the same question: where is everyone? Aliens might be looking for us, just like we are looking for them. This idea flips the Fermi paradox on its head. Instead of us wondering why they haven't contacted us, they might be wondering why we haven't contacted them. If intelligent life is rare, they could be searching, waiting, or even giving up hope that anyone else is out there. Imagine an advanced civilization developing on a planet orbiting a distant star. Over thousands or even millions of years, they create technology, build cities, and eventually develop space travel. They send probes to their neighboring planets, but they don't find anything. They turn their telescopes to the sky and begin scanning for signals. At first, they assume the galaxy must be full of life. There are billions of stars and countless planets. Surely, someone else must be out there. They listen, they search, but they hear nothing. At some point, they might start asking the same question we do. If intelligent life is common, why is no one responding? They may even build massive space telescopes far beyond our capabilities, searching the sky for signs of civilizations. They scan radio waves, look for artificial light from distant planets, and search for heat signatures from advanced technology. Nothing comes back. This might lead them to a simple conclusion: intelligent life is incredibly rare. Maybe they think they are the only ones. They might even believe that they are the first intelligent species to emerge in the universe. If they hold that belief, they may stop searching altogether. Why waste resources on something that doesn't exist? Now, let's consider another possibility. Maybe they believe intelligent life exists, but that it is spread so thin across the galaxy that civilizations almost never cross paths. The universe is vast beyond comprehension. Even if intelligent life appears on a million planets, those civilizations could be so far apart that they never hear from each other. By the time one species develops space travel and starts searching, the others may have already gone extinct. Civilizations might rise and fall like waves on a beach, never existing at the same time. A species that reaches an advanced stage of development might have to accept that reality. They could come to the conclusion that intelligent life exists, but communication is nearly impossible. The distances are too great, the timescales too long. If they send a message, it might take thousands of years to arrive at another inhabited planet. By the time the message reaches its destination, the civilization that sent it might be gone. If they receive a message, the sender could already be extinct. This could lead to a sense of cosmic loneliness. A civilization might put effort into searching for others, but after centuries of silence, they may give up. They may turn inward, focusing on their own survival rather than trying to reach out. If they believe intelligent life is so rare that the odds of contact are close to zero, they may stop looking altogether. There's also another possibility. Maybe they assume we exist but think we are not advanced enough to respond. When we look for intelligent life, we assume aliens will be more advanced than us. We imagine civilizations with giant space stations, faster than light travel, or immense energy collecting structures around stars. But what if an alien civilization assumes we are the advanced ones? If they are behind us technologically, they might not even be able to detect our existence. They could be stuck on their own planet, unable to send signals or build telescopes strong enough to see our world. They might be looking at the sky, wondering if there is anyone out there, just as we are. If they believe intelligent civilizations must be rare, they may assume they are the only ones. Now let's go one step further. What if they think we are there, but are deliberately staying silent? If they are advanced enough to consider this possibility, they might believe other civilizations avoid broadcasting signals to protect themselves. If they have theories similar to our dark forest hypothesis, the idea that civilizations stay quiet to avoid attracting hostile forces, they may assume intelligent life is hiding. This could lead them to a difficult decision. If they think other civilizations are staying silent for safety, should they remain silent too? If they believe an unknown danger is out there, calling attention to themselves might be risky. They might avoid sending signals for the same reason they assume others are silent. If every intelligent species follows this logic, then no one sends messages, and the galaxy remains quiet. Let's consider one final scenario. What if they do find signs of life but dismiss us as uninteresting? Maybe they see Earth, detect its atmosphere, and confirm it has life. But to them, that's not impressive. They might be looking for civilizations that have already mastered space travel or reached a certain level of technological advancement. If they see a planet with a species still in an early stage of development, they may decide it's not worth contacting. This would be similar to how we think about microbes on another planet. If we find bacteria on Mars, it will be an important discovery, but it won't be the same as finding intelligent life. An advanced civilization might see us the same way. They might view us as a primitive species, not ready for communication. If they follow some kind of ethical rule against interfering with less developed civilizations, they may choose to observe us from a distance, but never make contact. In the end, the reverse Fermi paradox suggests that we are not alone in asking where everyone is. Other civilizations might be out there, thinking the same thing. They could be scanning the sky, wondering why no one is responding. They might be searching, waiting, or even assuming they are the only ones left. If the universe is filled with civilizations that all believe intelligent life is rare, then no one reaches out and the silence continues. This perspective offers a different way to think about our search for extraterrestrial life. Instead of assuming that aliens are avoiding us or that they don't exist, it may be that they are just as uncertain as we are. They may have reached the same conclusions, made the same guesses, and struggled with the same unanswered questions. If that's the case, then the only way to break the cycle is for someone to take the first step. Maybe that's us. If every civilization assumes others are too rare or too far away, then no one makes the first move. But if just one civilization, ours or theirs, decides to send out a clear message, the silence could finally be broken. For now, we keep listening, keep searching, and keep asking the same question they might be asking. Where is everyone? Imagine a civilization so advanced that it no longer needs to fight for resources, struggle for survival, or even remain awake most of the time. Instead, it has perfected the art of hibernation, a long sleep stretching across millennia. This idea, known as the sleeper's hypothesis, suggests that extraterrestrial civilizations may exist, but remain dormant for vast periods, only waking for brief moments before returning to slumber. If true, this could help explain why we see no clear signs of alien life, despite the immense number of planets in the universe. A civilization that has mastered technology would likely reach a point where energy and resources are no longer immediate concerns. Once a society controls its needs completely, it may choose to optimize for long-term survival rather than constant activity. Space is not a friendly place. Cosmic radiation, asteroid impacts, and the slow death of stars make existence a challenge even for the most advanced beings. But what if a civilization could reduce these risks by slowing itself down? Instead of constantly expanding or consuming resources, it could simply wait, preserving its energy and only waking when necessary. The universe operates on a much larger timescale than human life. Stars live for billions of years. Galaxies take millions of years to collide. Compared to that, human civilization has barely lasted a fraction of a cosmic second. If an intelligent species thinks long-term, it might not operate on our timescale at all. What seems like total silence from the cosmos could just be the deep sleep of civilizations that operate on cycles of tens of thousands, even millions of years. Consider a species that has mastered artificial intelligence, biotechnology, and energy conservation. Instead of remaining active, constantly searching for new frontiers, it could create vast hibernation systems that allow it to slow time for itself. Its biological or synthetic minds could enter a controlled sleep, reducing energy needs to almost nothing. Only once every few thousand years would it wake, assess the state of the universe, make adjustments, and then return to sleep. If an advanced species follows this pattern, it would be nearly impossible to detect. Human civilization has only been using radio signals for a little over a century. If aliens wake only once every 10,000 years, there is an extremely low chance that their activity would overlap with the brief window in which we are looking. We could be scanning the sky during one of their long sleep cycles, completely unaware that in just a few centuries or millennia, they will wake, send out signals, or begin traveling once more. This idea also explains why we have not found massive space structures like Dyson spheres, which should be visible if civilizations were constantly growing. Instead of continuously expanding, an ancient civilization might have already built its infrastructure long ago, set up systems to keep it running, and then entered a dormant phase. If its technology is designed to last millions of years, it might have no reason to build anything new for a very long time. A species capable of hibernation might also avoid risk in a way that makes it invisible to us. If it recognizes that being active increases the chance of drawing attention from hostile forces, it could choose long sleep cycles as a survival strategy. In a universe where other civilizations might exist, staying quiet for long periods could be a way to avoid detection. The fewer signals it sends, the lower the chance it will attract unwanted attention. Human history offers small examples of this kind of thinking. In extreme cold or resource-scarce environments, some animals enter hibernation or periods of slowed metabolism to conserve energy. Ancient civilizations sometimes withdrew from expansionist policies, entering long phases of reduced activity to avoid overextension or external threats. Now imagine this principle applied at a galactic scale, with a species so advanced that it no longer needs to interact with the universe constantly. One possibility is that civilizations that do wake up at different times never overlap. If an alien species wakes for only a few hundred years every 10,000 years, and another civilization operates on a different cycle, they might never encounter each other. Each might be scanning the cosmos during its wake period, only to find nothing because every other intelligent life form is still asleep. Another scenario is that a civilization chooses to stay asleep until it detects a specific trigger. Perhaps it has automated systems watching the galaxy, and it only wakes when it detects new intelligence, significant cosmic events, or signals that indicate the presence of another advanced species. If it does not yet see anything of interest, it simply remains asleep. This could mean that humanity is being observed, but not actively engaged. If an alien civilization has monitoring technology far beyond our understanding, it might already know about us, but see no reason to wake yet. If we are still too primitive to be of interest, or if we pose no threat, it could remain dormant, waiting for a future where we become advanced enough to warrant interaction. If civilizations function this way, it creates a very different image of the galaxy. Instead of being a vast, silent void, the universe could be filled with sleeping giants, civilizations that have long surpassed the need for constant activity. They could be spread across different star systems, each in a state of near-permanent hibernation, occasionally waking, making small adjustments, and then returning to sleep. One challenge with this idea is how we could ever detect such civilizations. If they are not broadcasting signals, not building new structures, and not actively exploring, their existence would be almost impossible to confirm. The only signs might come from remnants of their past activity, abandoned megastructures, unusual energy readings, or unexplained anomalies in distant star systems. If we ever find a Dyson sphere or an artificial construct around a star but see no further activity, it might be the relic of a sleeping civilization, waiting for its next wake cycle. It also raises the question of what might eventually wake these beings. Could a galaxy-wide event, such as the emergence of many new intelligent species, trigger a collective awakening? If enough civilizations reach a technological threshold, perhaps the sleepers would all rise at once, ready to interact, explore, or take action in ways we cannot yet predict. For now, the sleepers hypothesis remains one of many explanations for why the universe appears so empty. It challenges the idea that intelligence must always be restless, always expanding, always seeking. Perhaps the greatest civilizations do not burn brightly, but instead endure through long cycles of sleep and wakefulness, moving to the slow rhythm of the cosmos. If that is the case, then we may be looking at a galaxy full of intelligent life, life that is simply waiting for the right moment to wake. If an advanced alien civilization follows a strict rule of non interference, the question is why? What would make an intelligent species observe but never interact? And if such a rule exists, who enforces it? The idea raises several contradictions. If life is common in the universe, there should be many different civilizations at different levels of development. Some might choose to interact while others might stay silent. A universal rule suggests some form of governance, cooperation, or even enforcement. That leads to more questions. How did such a rule come to be? What keeps every civilization in check? And why hasn't one group of aliens broken the silence? Consider a scenario where an advanced alien species, having mastered interstellar travel, stumbles upon a planet with a young civilization. They have the power to uplift this species, share knowledge, or even manipulate its development. But they don't. They remain hidden, observing from afar. This decision isn't random. It follows a guiding principle: non-interference. But how did they reach that conclusion? One possible explanation is history. If an alien species once interfered in another world and saw the consequences, they might have learned that interference causes harm. Think of human history. When technologically advanced societies encountered less advanced ones, the result was often destruction, whether through war, disease, or cultural collapse. If aliens saw a pattern where interference led to the downfall of civilizations, they might adopt a strict rule against it. They would see intervention as a risk, even with good intentions. The only way to prevent unintended harm would be complete isolation. Another possibility is ethical evolution. A species that survives long enough to become interstellar likely undergoes significant social and moral changes. If they recognize the value of independent cultural development, they might see interference as unethical. They may believe that civilizations must grow and progress at their own pace. Just as some human societies value the preservation of uncontacted tribes, an alien species might believe that young civilizations should remain untouched. Then there's the question of enforcement. If a single species decides not to interfere, that doesn't mean others will follow. The idea of a universal law implies either cooperation or control. If civilizations agree that non-interference is necessary, they might form an alliance to uphold it. This would require communication and organization at a galactic level. The alternative is more extreme: an enforcement system. If a powerful civilization enforces the rule, it might monitor the actions of others, ensuring that no species violates the law. This introduces the idea of galactic policing. A group of powerful civilizations might act as guardians, punishing any species that interferes with a developing world. This leads to another paradox. If non-interference is the law, but enforcement requires action, then interference happens anyway. A more unsettling explanation is fear. Perhaps civilizations stay silent not because they choose to, but because they have no choice. A more powerful force may impose the rule, preventing contact through intimidation or direct suppression. Imagine an ancient civilization that once ruled the stars. It established control over thousands of species and imposed strict laws. Though it may no longer be visible, its influence lingers. New civilizations grow under the shadow of its past enforcement. No one dares to break the rule because they fear consequences. The mere possibility of punishment keeps them in check. Another scenario considers intelligence itself. What if advanced civilizations don't interfere simply because they don't see the point? To a being millions of years ahead of us, our concerns, struggles, and even existence might be insignificant. They may not ignore us out of ethical concerns or fear, but out of indifference. Imagine humans observing ants. We see them, but we rarely interfere unless they become a problem. To a vastly superior intelligence, the affairs of a developing species might hold no interest. This raises another contradiction. If civilizations are indifferent, why observe at all? If they watch but never act, there must be a reason. Either they are waiting for something, or they follow a strict rule. But if they follow a rule, we return to the question of why. There's also the possibility that the rule is not absolute. Some species may choose non-interference, but others might ignore it. If even one civilization decides to break the silence, we should have evidence. That we don't suggests either an extreme level of cooperation or an extreme level of suppression. Either all advanced civilizations agree on non interference, or those that try to break it are silenced before they can reach us. Both possibilities lead to contradictions. If every species agrees, there must be a way to reach universal consensus, which itself suggests some form of galactic governance. If civilizations are silenced before they can reach us, then someone or something is watching. This also connects to the idea of a hidden observer. If non interference is a rule, but enforcement is invisible, then how is the rule upheld? This suggests monitoring. If a civilization watches developing species to ensure they remain untouched, they must have detection systems in place. If they can detect violations, they can act against them. That raises the question of how far their reach extends. If they monitor one planet, they likely monitor many. This would require vast resources and coordination. Such a system would not be accidental. It would be a deliberate structure, possibly maintained by a civilization so advanced that it can remain hidden even while watching countless worlds. Another angle considers the role of time. If civilizations rise and fall over millions of years, the rule of non-interference might not be permanent. It could be a phase in the development of advanced societies. Some may follow it strictly, while others abandon it over time. If this is true, then the silence we experience may not last forever. Given enough time, a civilization might break the rule. The question then becomes, has this happened before? If one civilization once intervened in another's development, what was the result? If the outcome was catastrophic, that might explain why others now refuse to act. The prime directive paradox forces us to ask what kind of civilization would create and maintain a rule of non-interference. It requires a level of coordination that seems improbable, unless advanced species communicate and cooperate in ways we don't yet understand. It also suggests a reason for their silence, whether ethical, practical, or fear-based. If non-interference is universal, then something enforces it, whether through consensus, monitoring, or intimidation. If it's not universal, then we should expect at least one civilization to break the rule. The fact that we don't see any interference suggests that either we are missing something or that enforcement is stronger than we can imagine. The paradox remains unresolved. If aliens exist and they follow a rule of non-interference, the question is not just why they do it, but how they maintain it across a vast and diverse galaxy. Imagine a civilization reaching a point where it no longer advances. It has mastered its environment, developed incredible technology, and eliminated most challenges. At first, progress was rapid: fire, agriculture, industry, space travel. But then, the momentum slowed. Eventually, it stopped. This idea suggests that most alien civilizations may reach a peak and never move beyond it. They don't disappear, but they also don't expand across the stars. They exist in a steady state, comfortable but unchanging. Consider Earth's history. Humans once saw rapid breakthroughs: steam engines, electricity, spaceflight. But today, major leaps are less common. Advances in physics, medicine, and engineering continue, but they build on existing knowledge rather than shattering old paradigms. If our civilization continues in this pattern, we might reach a point where we no longer push forward in meaningful ways. Now, apply this idea to alien civilizations. A species might develop advanced computers, fusion energy, and space habitats. It might even terraform planets. But once it achieves a stable, self-sustaining society, what would drive further progress? If resources are abundant and every need is met, there may be no motivation to expand. Growth often comes from necessity. If a civilization solves its problems, it may stop seeking new challenges. Consider an alien race that has harnessed renewable energy perfectly. They have AI managing everything, eliminating hunger, disease, and manual labor. They live in vast, comfortable cities, or perhaps underground, safe from cosmic radiation. They have no wars because their needs are met. They have no pollution because they perfected energy use long ago. In this state, what would push them to build interstellar ships or colonize distant planets? They may see no reason to venture beyond their home system. There's also the issue of diminishing returns. In science, new discoveries often require more effort than past breakthroughs. The first radio signals were easy. The first nuclear reactor was simple compared to today's energy research. The Large Hadron Collider took decades to build and cost billions, all to study particles that have little impact on daily life. If an alien society reaches a point where research is too expensive or progress is too slow, they may decide it's not worth it. They may have the ability to build warp drives, but lack the incentive. Think about technology in your own life. A smartphone from 10 years ago could call, text, and browse the internet. A new phone today does the same things, but slightly faster with a better camera. The core function hasn't changed much. If this pattern continues across an entire civilization, its advancements may become minor refinements rather than leaps forward. Cultural stagnation could play a role as well. A species that reaches a stable society may shift its focus from innovation to tradition. If every citizen enjoys a perfect life, why change anything? On Earth, some civilizations remained unchanged for thousands of years. Ancient Egypt had the same basic government, writing, and architecture for over 3,000 years. China's core culture persisted for millennia. If an alien society found a way of life that worked perfectly, it might never see a reason to alter it. There's also the possibility that technological stagnation happens by design. A civilization might deliberately limit its own progress to avoid risks. On Earth, nuclear weapons showed that powerful technology can also be dangerous. If aliens reached a point where new discoveries posed more risks than benefits, they might decide to stop. An AI superintelligence might conclude that expanding into space is unnecessary. A governing body might enforce strict regulations to prevent disruptive innovations. Over time, progress might grind to a halt. Another factor is lifespan. If an alien species has a long lifespan, its motivation to innovate might decrease. Humans often push forward because lifetimes are short and people want to leave a mark. But what if a species lived for thousands or millions of years? Would they feel the same urgency? If an alien scientist knew they had eternity to explore a problem, they might take their time, centuries or millennia, before making breakthroughs. This could slow progress to a crawl. Biological needs could also play a role. If an alien species evolved to be perfectly adapted to its homeworld, it might see no reason to leave. Humans have a strong drive to explore, but that's not universal. Some animals never leave their territories. Some people are content staying in the same town their whole lives. If an intelligent species evolved with little curiosity, it might never push beyond its immediate surroundings. There's also the possibility that once a civilization reaches a certain level, it simply stops needing anything new. Imagine a society that has solved every problem. Food, energy, and shelter are unlimited. Health is perfect. Entertainment is endless. Work is unnecessary. At that point, what would push them forward? They might live in virtual realities, lost in perfect simulations. They might meditate for centuries, uninterested in physical expansion. They might see space travel as crude and unnecessary when they can explore digital worlds without risk. Some argue that intelligence leads to expansion by default. If a civilization can spread, it will. But this assumes expansion is always desirable. On Earth, some groups choose isolation over growth. Some societies reject technology in favor of simpler lives. If an alien race reached a point where it could expand but saw no benefit, it might choose to stay where it is. It might view the stars as dangerous or unnecessary. The result is a universe full of civilizations that never leave their planets or home systems. They exist in a steady state, thriving but not advancing. This could explain why we don't see evidence of aliens. They're out there, but they aren't expanding, colonizing, or sending signals. They may have reached a point where they simply don't need to. If this is true, it changes how we think about the search for extraterrestrial life. Instead of expecting a galaxy filled with explorers, we might find ancient civilizations that have been the same for millions of years. We might discover worlds with vast cities but no spacecraft, or planets where alien AI maintains society while the biological species has retreated into digital worlds. The universe might not be empty. It might be full of life that has chosen to stop moving forward. This raises questions about humanity's future. Will we continue to advance indefinitely, or will we also reach a plateau? If technology ever reaches a point where life is perfect, will we still seek more, or will we become like the civilizations we search for, present but silent? Imagine a civilization that has reached a point where it can send signals across the galaxy. It has the technology to listen, to observe, and to announce its existence. But it chooses not to. It remains silent, not because it lacks the means, but because speaking up might be dangerous. This is the heart of the anti communication paradox, the idea that intelligent civilizations deliberately avoid contact because the risks outweigh the benefits. At first, this may seem counterintuitive. When humans developed radio technology, we immediately started broadcasting. We sent signals into space with no concern for who might be listening. The assumption was that if intelligent life was out there, making contact would be beneficial. We imagined peaceful exchanges, shared knowledge, and the possibility of alliances. But this view assumes that other civilizations think the way we do, and that the universe is a safe place. There's no reason to believe either of these things is true. A more cautious civilization would recognize that reaching out carries potential dangers. If they make themselves known, they might attract attention from a species that is not friendly. In human history, whenever a more advanced civilization encountered a less advanced one, the results were often disastrous for the weaker party. Indigenous populations faced conquest, exploitation, or destruction when explorers arrived. If space follows a similar pattern, then a wise civilization would remain silent rather than risk inviting a stronger unknown force to its doorstep. Another reason for silence is the simple fact that not all civilizations will have the same motives. Some might be explorers, looking for knowledge and cooperation. Others might be expansionists, seeking resources or territory. There's no way to predict which type would respond to a signal. A civilization that broadcasts without thinking could be making a fatal mistake. Even if an advanced species has no intention of harm, they might interfere in ways that are catastrophic simply because they don't understand the consequences for the lesser species. A well-meaning but powerful civilization could cause as much harm as a hostile one. A cautious species might also recognize that the mere act of communication could expose weaknesses. By studying the patterns in a signal, an advanced civilization could determine the sender's level of technology, energy consumption, and even details about their biology. This information could be used against them. Even if the receiving civilization had no hostile intentions, they might share the knowledge with others who do. In a universe where the balance of power is unknown, silence might be the safest strategy. There's also the possibility that civilizations who ignore these risks don't last long. If the universe contains many intelligent species, it's likely that some have made the mistake of broadcasting their presence. If an aggressive species is out there, those civilizations may no longer exist. This would explain why we haven't heard from anyone. The ones who called out were removed, and the ones that survived learned from their example. Imagine a world where a civilization reaches a technological peak. They have mastered energy production, space travel, and artificial intelligence. They expand into their solar system and begin exploring beyond. At some point, they detect an ancient distress signal from another civilization. The message is clear: we are here. We need help. The explorers analyze the transmission and discover that the civilization that sent it vanished thousands of years ago. The signal kept traveling through space, but the people who sent it are long gone. They begin investigating what happened. Their probes scan the ruined world where the signal originated. It's clear the civilization once thrived. Cities stretched across continents, great machines harvested energy from their star, and they had an active presence in space. But now there's nothing. No survivors, no signs of war or environmental collapse, just silence. Their research uncovers a second message, one that was never meant to be found. A warning, buried deep in the remains of their technology: do not speak, do not call out. We were heard. This scenario presents a chilling possibility. What if there are rules in the universe that we don't yet understand? What if there is a pattern, an invisible order, enforced by those who have the power to act? If a civilization reaches a certain threshold and becomes loud enough, they might attract attention from something far more advanced. And if that advanced force believes in keeping order, it might remove those who disrupt the silence. A civilization that recognizes this risk would likely take steps to prevent exposure. They would establish strict communication protocols. Any signals they send would be encrypted or disguised as natural cosmic noise. They would use passive observation rather than active broadcasting. They might even teach their younger generations that seeking contact is reckless, that silence is survival. If the anti communication paradox is true, it means that the absence of alien contact is not evidence of an empty universe. It could mean the opposite. The galaxy might be teeming with life, but all of it is hiding. Everyone is listening, but no one is speaking because speaking is dangerous. There is also the possibility that civilizations that do not adopt this strategy inevitably expose themselves and get removed from the equation. A pattern might exist where naive civilizations reach a certain level of development, start broadcasting, and are quickly detected and neutralized by a more advanced force. The ones who survive are the ones who learn to remain silent. Another unsettling implication is that if we do hear a signal, we should be very cautious about responding. If another civilization is broadcasting, there are only a few possibilities. They might be extremely confident in their strength and have no fear of revealing themselves. They might be desperate, taking a final gamble to reach out before they disappear. Or they might be something entirely different, something that wants to attract attention. In any of these cases, responding without knowing the consequences could be a mistake. Humanity has already sent messages into space, hoping to make contact. We have broadcasted radio waves for over a century, leaking our presence into the cosmos. We have sent physical messages on spacecraft, hoping they will one day be found. These actions assume that communication is safe. But if the anti-communication paradox is correct, we may have already made an irreversible mistake. It is possible that more advanced civilizations have detected our signals but have chosen not to respond. They might have rules against interference, or they might be waiting to see if we learn to stop broadcasting before it's too late. If we suddenly become silent, it could signal that we have matured, that we understand the dangers. If we continue to broadcast recklessly, it might mark us as a species too careless to survive in the larger cosmic ecosystem. The idea of a silent galaxy changes how we think about the search for extraterrestrial intelligence. Instead of asking why we haven't heard from anyone, we should consider whether we should be trying to hear at all. If advanced civilizations are staying quiet for a reason, then perhaps we should be listening to their silence. A universe where everyone is hiding suggests that survival favors those who remain unnoticed. It suggests that danger exists, even if we don't yet understand what form it takes. If we accept the anti-communication paradox, then the absence of contact is not a mystery, it is a warning. Imagine standing on a quiet beach at night, looking out over the vast ocean. The waves roll in, steady and endless, but beneath that surface, there is an entire world. Deep down, where no sunlight reaches, life exists in ways that seem almost impossible. Giant squid drift through the dark, bioluminescent creatures light up like stars, and ancient fish move silently, unaware of the world above. Scientists have explored only a small fraction of these depths, even though they cover most of our planet. This should make us think. If so much life exists right here on Earth, hidden in plain sight, what does that say about the universe? Maybe the same thing is happening on a much larger scale. When people think about extraterrestrial life, they often picture something obvious. They imagine massive alien ships hovering over cities or radio signals beaming in from distant planets. But if Earth teaches us anything, it's that life doesn't always announce itself. It can thrive in places we least expect. The deep ocean is proof. For centuries, humans believed nothing could survive in the deepest parts of the sea. The pressure is crushing, the temperature is near freezing, and there is no sunlight. By all logic, it should be lifeless. And yet, when scientists finally sent cameras into the abyss, they found ecosystems teeming with creatures that had adapted in ways no one predicted. The same assumption happens with space. People often think of it as empty, cold, and silent. But emptiness is a matter of perspective. The deep ocean seems empty until you look closely. What if space works the same way? Maybe alien life is common, but we just aren't looking in the right way. Our methods rely on detecting signals or seeing physical structures, but what if intelligent life exists in a form we don't recognize? If an alien species evolved under completely different conditions, their way of communicating, or even existing, might be beyond our understanding. Think about the creatures in the deep ocean. Many produce their own light. If they tried to study life on the surface, they might assume that without bioluminescence, nothing could survive. They wouldn't know about sunlight or vision as we experience it. In the same way, humans might be searching for alien life using assumptions that don't apply. We listen for radio signals because that's how we communicate over long distances. But an advanced civilization might use a different method, one that doesn't leave a trace we can detect. There's also the possibility that alien life prefers isolation. Deep sea creatures don't interact with the world above. They have adapted to a specific environment and have no reason to leave. A similar principle could apply to extraterrestrial civilizations. If they exist in a stable, self-sufficient state, why would they need to explore? Just because humans are driven to expand and discover doesn't mean all intelligent life shares that instinct. Some civilizations might be perfectly content staying where they are, never reaching out. Another problem is scale. The ocean is vast, but the universe is beyond comprehension. Even if intelligent life is out there, it could be so far away that we'll never cross paths. Deep sea explorers can spend years searching for a single new species. Now imagine trying to do that across light years. The odds of finding alien life might be slim, not because it doesn't exist, but because it's too spread out. If deep sea life only revealed itself once we developed the right tools, maybe the same thing needs to happen for space. Our current technology might not be enough. Consider another perspective. Some of the strangest creatures on Earth live in hydrothermal vent communities. These are places on the ocean floor where hot, mineral-rich water pours out from cracks in the Earth's crust. No sunlight reaches these depths, yet entire ecosystems thrive, fueled by bacteria that convert chemicals into energy. This discovery changed how scientists think about life. Before, they believed all life needed sunlight. Now they know that's not true. If alien life exists, it could be using energy sources we haven't even imagined. One of the most likely places to find extraterrestrial life is Europa, a moon of Jupiter. Beneath its icy surface, scientists believe there is a vast ocean, possibly larger than all of Earth's combined. If life exists there, it would be living in complete darkness under extreme conditions, just like deep-sea creatures here. The same could be true for Enceladus, a moon of Saturn, which also has a subsurface ocean. The more we learn about extreme environments on Earth, the more we realize that life is adaptable. If it can exist in the deep ocean, it might exist in deep space. Another possibility is that intelligent alien life is already here, but we don't recognize it. There could be a form of life so different from our own that we overlook it entirely. Some scientists have suggested that extraterrestrial life might exist as plasma-based entities or in forms that do not rely on carbon chemistry. If true, we could be surrounded by life and never know it. Deep-sea creatures live in our own oceans, yet most people will never see them. The same thing could be happening on a cosmic scale. Humans often assume that if aliens exist, they would want to communicate. But communication depends on shared experiences. Deep-sea fish have no concept of the surface world, so they have no reason to reach out. If extraterrestrial life is vastly different from us, it might not even consider us worth noticing. A species with a completely different perception of time might not communicate in ways we understand. They could be sending messages that take thousands of years to arrive, or their entire civilization might exist on a timescale that makes interaction impossible. There's also the question of intelligence. People often think of intelligence in human terms: language, technology, problem solving. But intelligence comes in many forms. Octopuses are incredibly smart, yet they don't build cities or use radio signals. An advanced alien species might not leave the kind of technological traces we expect. If their intelligence took a different path, they could be thriving in a way that doesn't resemble anything we know. The deep ocean reminds us that life can exist in places we once thought impossible. It also shows us that just because we don't see something doesn't mean it isn't there. If we apply this thinking to space, it changes how we view the search for extraterrestrial life. Instead of expecting obvious signs, we should consider the possibility that life exists in ways we haven't imagined. Maybe the universe is teeming with life, hidden beneath cosmic oceans, just like the creatures in our own seas. We just haven't found the right way to see it yet.